Hello everyone, this side Asta Goswami, and today I am presenting a new topic which is a part of the central tendency and one of the type of mean, harmonic mean. So let's get into the definitions and understand the definitions deeply, that what is harmonic mean. So HM of a series of values is obtained as the reciprocal of the arithmetic mean of the reciprocal of the individual value. So what is harmonic mean? Basically, it is a reciprocal of the arithmetic mean. What we have studied in the arithmetic mean, like x1 plus x2 plus x3 plus xn. Okay, whatever the n number. Okay, then we divide it by the n number of observations. So this is the formula of arithmetic mean. But in the harmonic mean, the individual observation is reciprocal. First we will reciprocal the whole mean formula. The n which is written in the denominator, now it is written in the numerator, and the x1 x2 x3 is written as denominator, and then this x1 x2 x3 is written as the reciprocal. So here 1 by x1, 1 by x2, 1 by x3 plus 1 by xn. So these are the composition. So hm is equal to n divided by 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by xn. So hm is equal to n by number of observation is what? xi. Then hm is the reciprocal. Here hm is the reciprocal. So we can write it by reciprocate that in the n is in the numerator. So now we will write it in the normal way, where 1 by xi is there and by n is there. So when we reverse the formula, so we have to write reciprocal. So in the formula we have written rec in the short form, and then we reciprocal again by 1 by xi into the normal form. So again we will write res. Okay, so hm is equal to res by reciprocal xi by n. So this is the final formula of the harmonic mean. Then we will go to the types of harmonic mean. So hm is of two types, simple hm and weighted hm. So as we have studied that simple hm is like simply it is just calculated, and in the weighted harmonic mean, or whenever we are taking any kind of observations, whether it is mean, mode or median, if we are giving some special importance to some of the values, you are giving the weight of some value. Let's suppose this subject is important for JEE, let's suppose physics and maths, so we are giving more privilege or more importance to the maths. Whoever gain good marks in the maths or physics, so they will be able to give the exams. But on the other hand, some of the students who are scoring good marks at PhD or some other subject, and ultimately they get the good marks, overall marks, but they are not able to pass in the physics or maths criteria in any kind of exams like NT and all. So they are rejected. So this is a this is an example of weight, where we are giving some importance to some of the specific observations according to our need and motive. Then we are talking about the simple hm. So hm gives the equal importance to all the observations in the series. Determination of shm. So here when you are making simple SHM simple in the simple series, sorry, in the individual series. So here there is no frequency, so the formula which we have already derived, so it is similar to that, where n and this is a way of writing any kind of formula. If the questions will be asked that write the HM formula, so you have to write it in the right order, and then HM is the reciprocal of n I is equal to 1, and this is the rest of the xi where we are reciprocating. So first we reciprocate the whole formula so that the reciprocal is written, and then in the internal way we have written res xi by n. Then here we are finding the HM. Okay, so here it is the x observation and here is res x, and if you have a reciprocal table, so it is better to calculate it, otherwise you have to calculate by your own. So here 1 by 32 is there, so in order to calculate or divide the 32 by 1, you have to take a decimal and then again a 0, because in the decimal it could be 10, and by putting the 0 it will turn into the 100, and then divide it, divide 100 by 32, 100 by 31, 100 by 36, 100 by 58, 100 by 61, 100 by 73. So in order to divide the 100, 0.0 will be added in each and everything, and whatever the value, this is the basically the division by this number to the 100. Okay, you are getting. Then res x is equal to 0.13493. So here this decimal is written, and HM is the rest of the reciprocal of the x by n. So here what is the summation of the xi? So here the value is where we have added all the observations, and then we have the n number of observations, so reciprocal is 0 point something like that, and n is the 6, and HM is res, and whatever the value divided by 6, and what we will get. Okay, so here HM is the res 0.249 and HM is, and this is the value where again you have to reciprocate the value. So when you have written when you will written 1 by 0.049, and after the removal of the decimal you get this answer 44.96 units. Okay, this is all about the calculation. It is a calculation but not that much. And then we have discrete series. So HM is equal to summation f 1 by x1 into f1 plus 1 by x2 into f2 plus 1 by xn into fn. So it is start by 1 by x1 into f1. So in the discrete series, what is the discrete series? So in the individual series only observation is there, and in the discrete series the observation is individual. It is like an individual but frequency will be added. Okay, so here the formula will be changed, like in the place of n there is a summation f, and in the whole observations like 1 by x1, 1 by x2, f1, f2 and up to the fn, it will be multiplied similarly to the arithmetic mean if you have studied. Then HM is equal to fi by xi, and because when you have multiplied x1, x2, x3 or added or anything, so in short we can write xi. Okay, so fi by xi, and then HM is reciprocate of fi by xi divided by fi. Okay, Then HM is the reciprocal of Fi, reciprocals of the Xi by Fi. So here what is written, that reciprocal of the Fi Xi, and here you again reciprocate, so where Fi reciprocal, so in the division there is a division like Fi by Xi, and because Fi is in the top and x1 x2 x3 it is in the denominator, and Fi is just multiplied with it, so Fi and Xi is there, and it is basically in the bottom. But when you reciprocate in the outer portions of the formula, here it is the reciprocal, so it reverses, and then when you reciprocate the inner formula, so here you can write Fi reciprocate by Xi, you can say that Xi by Fi. So here you can write like this, where reciprocate Fi res Xi by Fi. Okay, and this is all about the discrete series. Then we have illustrations where the question is find the HM. So in the HM, X observation is there, F observation is there, then the reciprocal X and F reciprocal is there. Okay, so when we have written the reciprocal of X, it means like 1 by 3, and when you calculate 1 by 3, 1 by 5, 1 by 7, 1 by 9, so you get 0.333, 0.2000, 0.1428, 0.111. Okay, so here what you get in the decimal form, and then write it in the frequency where you are multiplying it and you get this value. Then do the addition of F reciprocate with X, because the ultimate formula is there, so you have to find the value of this and this. Okay, so already we have calculated the summation of F, which is 100, and here we have calculated 20.0618%. Okay, and here we will put it in the formula where summation F reciprocate the X is there, and summation F is there 100, and reciprocal of this is, we have written it, and when you divide it all, then reciprocate again, where you can assume that 1 is there and put the 100 and then divide it and you get this answer. Okay, in the continuous series, what is the value? So in the continuous series, only one thing which is different, in the place of Xi, Mi is there. One step further, when X observation is basically in the range, so you have to calculate the mid value, and then the further process is similar to the discrete series. So here the continuous series is there, HM, N1 and I1 and Fi, and Fi Mi. Here HM is reciprocal, so here you can see that the formula is the similar, where HM is Fi divided by Fi by Mi. Okay, this is the formula, which is totally opposite to the arithmetic mean, and where you will reciprocate, and where the formula turn into the Fi by Mi, reciprocal of Fi by Mi, and divided by Fi. Okay, and the N and I index number is equal to 1 is followed by the formula. Then again the reciprocal will be there, so HM is equal to reciprocal of the Fi reciprocal to the Mi divided by summation of the Fi. So this is also in the summation, and this is also in the summation. So this is the formula of the continuous series. Here the illustration is there, where the values is in the x-axis in the range, and here you have calculated the mid value, then frequency is there, and then the formula will be followed, where reciprocal of M will be calculated, and then first you have to calculate the reciprocal of m, because the f is the f will we will take the f as the normal, and in the further question also we don't have to do anything with the frequency. All the calculations will lead in the observations, whether you are turning into the mid value and after doing any kind of calculation, so it is based on that only. In the frequencies as it is, whatever the further analysis will be there, then we will calculate the mid values and then reciprocal of m and f reciprocal of m. So whatever the value we get from that, so reciprocal of m is what, for 1 by 45, where 0.0 will be there, and you have divided 100 by 45 and you get this answer. Then f press m, where you are multiplying it and you get this values, and summation fi rest mi, and you get this answer. Okay. So this is all up, and you have written the you have to write the formula for the continuous series. Here what is written, summation of fi summation of f reciprocal of m, we have calculated by the formula, which is 3.4344, and the summation of the f is 246, and where we put all this formula. So the formula is as it is, but when you calculate it, so the whatever the formula, so we have to again put it is not like it just you have put the formula and you get the answer. So reciprocal, one reciprocal is already there, one reciprocal is done by the table, and one reciprocal you have to do after putting the formula, which is the outer reciprocal, and then the value you have divided again reciprocate by the 1, and of course this value is in the 0.0, so it is smaller than 1, and you have this value, and you must write the unit is must, because the unit will be there, whether in the question it is written kilometer, liter, and whatsoever, you have to write the final answer with the unit. Okay. Because this is not a relative value, it is the absolute value. You have to you have calculated the absolute value, this is not a deviation or something like that, so unit will be must. Then we will start studying the WHM, which is weighted harmonic mean. So it is different from the weight are assigned to the different values of the series, and WHM is used as HMW is equal to WI by XI. Okay, so here the reciprocal formula is there, and you can see that in the place of fi, wi is written, and wi and fi is kind of similar, not that similar but kind of similar. So in the place of fi, wi is written. It is like in the discrete series xi is there, and in the continuous series mi is there, so it is like exchange with the frequency. Then WHM is there, and it is reciprocate with the summation WI by reciprocal of XI by summation WI. Okay. Then we have the formula, find the WHM, where the XW reciprocal of X, W reciprocal of X is there. So we have put it all the formula in the X, in the W, then reciprocal of 0.0250. So we have calculated the reciprocal of the X. Okay. So first we have to calculate the reciprocal of the X, because all the calculations will be done in the x observation, and when and w is like a frequency, and in the w reciprocal by x is there, where we will multiply it with the reciprocal of x, whatever we have calculated, by the divide of the 1. So the value is there, it is similar to f reciprocal by x. So you get the summations w reciprocal x, and which is 0.4388, and then put it in the formula where 0.4388 is there, and divided by the summations of the w, which is 25, and you put this in the formula, and the reciprocal is there. So here whatsoever the answer is there, then reciprocate, and 0.0175, and then again reciprocate, and you get the answer 56.934 units, because you are dividing it with the 1 where all the zeros will be put it. So if the value is like 1000 and you are dividing it by 175, so of course the answer will become 56.934 units. So this is all about the weighted harmonic mean. We have studied the simple harmonic mean. In the simple harmonic mean, there are 3 types of series: individual series, discrete series, and continuous series. Then we have studied the weighted harmonic mean, where one type of question is there. Then we will move to the mathematical properties of the harmonic mean. Here we go. First is property 1. So for two positive observations, the following relationship holds true. So am multiplied by hm is equal to square of gm. Okay, so this is a relation between the type of the mean. Am multiplied by hm is equal to square of the gm. So two positive observation following the relationship holds true. So here there is two positive observations, and which is a square of the geometric mean. So this is the property 1. So for two positive observation, the following relationship will hold true. So if the observations is the true, is the positive, I mean in the arithmetic mean or harmonic mean, the mean is the positive. So where the both are multiplied is equal to square of the geometric mean. So it is also helpful for the questions, if the questions will be asked that suppose the arithmetic mean is this and harmonic mean is this, so find the geometric mean. So what you have to do, whatever the arithmetic mean is there and harmonic mean is there, just multiply it and you get the square of the geometric mean, and after rooting you get the exact geometric mean. Okay, because the geometric mean formula is under the root. So here's the answers, and you can also find it the other things, like in the questions geometric mean is there, and there is the absence of arithmetic mean or either harmonic mean. So you can find it by simplifying the formula. Like if you want to find the harmonic mean with the help of arithmetic mean or geometric mean, so what you have to do, just square of the geometric mean divided by the arithmetic mean, and if you want to calculate the arithmetic mean, so geometric mean is square divided by the hm. So it is like that only. Then we have the property second. It is that for n number of positive observation, the following property holds true. Okay, so the let's suppose I am not calculating the number of observation, it is let's assume that it is the n number of observation. So first is the value whatever it is get, the arithmetic mean will be the highest, followed by the geometric mean, followed by the harmonic mean. Why it is so? Because the fluctuations, the weightage of the high values or the low values I meant to say that large observations are highly effective in the arithmetic mean. On the other hand, the deviations in the geometric mean or harmonic mean is comparatively very low as compared to arithmetic mean. Okay, so here there is a property 3. If all the values of the variables are the same, then the HM of the observations will also be same. So here we have studied that the observations value, there is a here the large observation or the least observation is deeply affected with the arithmetic mean, and that is the reasons. If we are calculating the mean and the values are very high, the observation is high, so it is obvious that arithmetic means unable to eradicate those impact of the observations, and that is the reasons why the arithmetic mean is greater and the geometric mean are followed by it, and harmonic mean is also followed by it. Okay, then we have the property 3. If all the value of the variables are the same, then the HM of the observation will also be same. So if all the value of the variables are the same, okay, then the HM of the observations will also be same. So if the all the observation is same, okay, and if all the values of the observations are the same, so if all the values of the observation is same, let's suppose the all the observation is 2. Okay, if we are taking the individual series, let's suppose, so all the observation is 2. Okay, it is repeated to 5 times. So what would be the answer? 5 times we are when we are adding the 5 times 2, so the answer will be the 10, and the observation is, of course the observation is 5, so and numbers, then the value is 2. Okay, but when you are calculating the geometric mean or harmonic mean, not only the arithmetic mean, so the value will be the same. It is not like it is affected by anything else. Okay, then we have property 5. So if any of the two if any two of the three factors, that is HM and or reciprocal of x, as we have know the basic formula where HM, then reciprocal of the x is there and n is there. Okay, these three things is there, then are given, the value of the third unknown can be easily find out. So if the three values written, so we can easily find out the third value. So let me understand you by the formula, like thus HM is equal to n by reciprocal of x. This is the formula. So if any value of this is unknown and two values has been given in the question, so you can easily find out the third value. Okay, so here if you want to find out the HM, n is there, reciprocal of summation reciprocal of x is there, so you can just simply put it in the formula and divide it, so you can get the HM. Let's suppose n is absence in the HM series, so what you have to do, just multiplied HM with the summation of the reciprocal x. Okay, and if the summation of the reciprocal x is absence, then you have to write n by HM. Okay, then you get the reciprocal of the x. Then we have property number 6. If there are two or more groups whose individual numbers of observations are respective, HMS are given and we can find out the combined HM. So it is like similar to the arithmetic mean, where the property of the combined mean is there. So here, if there are two or more groups, those individual number of observations and respective HNMs are given, and we can find out the combined mean. I meant to say that if there is two or more groups, okay, I mean that you have to calculate this group's mean, then this group mean, and this group means. So two or more observation groups were there, and they have their separate observations. Those individual number of observations and respective HMS are given, and we can find. So where the individual number of observation is there, respective HMs are given, and we can find out the combined HM. So where what is written, the observation is written, that what is the number of observation, I mean n is given, and the respective HM, for one group the HM is that, for another group the HM is that. So here this is like that only. And thus for k number of series, let's suppose the k number of series, here if the values are known, so we generally write n or k, especially in the number of observations we have, we can write n, and in the number of scale we just simply like number of series, so we just simply write k in the holistic view. So here HM is 1 2 3, let's suppose k number of HM is there, okay. Then the number of observation is n1 plus n2 plus n3 plus nk up to nk. Then here it by reciprocal is summation of reciprocal x1 plus summation of the reciprocal x2 dot to summation of the reciprocal k. Okay, this is the last one, which is the unknown. What would be the answer? So here you can write n1 n2 n3 n4 to nk, and here you can reciprocate it like you so here the reciprocal of x1 x2 x3 is there. So you have to simplify it. How you can simplify it? Just simply write n1 by hm1. So how it is written? Like summation of xi. So here here we have put the property 5, okay. So here you can see that reciprocal is n by hm. So we have put like for the 1 observation, for the 2 observation, for the 3 observation, for the k number of observations. Here 1 2 3 4, how we can write hmi. Here ni and ni, then summations, and here the k number is there. So this is the formula of the combined mean. You can see that it's combined mean cm. You can also write it is up to k, where ni divided by ni by hmi. So here you know that how the formula is derived, but the most important is to remember this formula. If the combined harmonic mean is there, and you know the harmonic mean and number of observations, so ni by ni divided by hmi, and then calculate it so that you get the combined harmonic mean. Then let's move to the merits and the demerits of the HM. So based on all the observations, so here in the not only the harmonic mean, if you have studied the arithmetic mean, geometric mean, averaging is conducted to all the observations. So based on all the observation is HM is calculated after taking into the account all the observations of the series, and it thus represents the entire series. So it take all the observations, so it is representing the entire observation. So this is one of the merit of the harmonic mean. Then move to the second one, which is the less weight to large values. Here the large observations doesn't impact the harmonic means. Okay, since the HM is based upon the reciprocal of the original observation, so it gives less weight to large items and more weight to smaller items. So here the when reciprocation is there, so you know that reciprocal, when you reciprocate the value, so whole the scenario will be changed. Let's suppose 1/2, and you are taking example of which is greater, 1/2 or 1/4. So it is must that 1/2 is greater than 1/4. Okay, so it is like that, where you are reciprocating. So what you are doing, you are giving more value to the less you are giving more weight to the smaller values and less weight to the higher values, and it compensate where the impact of the epic observations will be fine. Okay, so since HM is based upon the reciprocal of the original observation, and it gives less weight to large items and more weight to smaller values. Then we have third, which is applied in widely dispersed series. So since HM gives less weight to larger items of the series, so this average is useful in the case of series which has wide dispersion. So here where it is given that it gives the less value to the larger items and of the series, and this average is useful in the case of the series which has wide dispersion. So here the deviation is very less. So if the dispersion is in the series, there is a large number of dispersion. Let's suppose the series have 1,000 in the x number of observation, and here some of the observation is only 2 or 3. There is the dispersion is very is there, dispersion is very there. And when you are putting the HM, so what it will do, it will compensate all the observations, and here the if the wide dispersion is there, so it is a better way to calculate it. Then we have helpful in calculating the rates. So HM is useful in calculating the average rate of values of the observation. So HM is helpful in calculating the average rate of the values of the observation. So it calculates the rate. If you have studied that HM is better to use in the calculation of the rate, that in which rate this is increasing. So here there is no deviations, this gives the original rate, that in which rate the price is decreasing. So there is no effect of the inflation or whatsoever. So where the deviations have no role to play, and the rate is basically to calculate the original form only. So it is helpful in calculating the rate. So what are the merits of the HM? So first it is based on all the observations. Then it gives less weight to the higher values and more weight to the lesser values. So this is like that. And then it is helpful in especially in the series where the dispersion is there, where the deviation is very less. Okay, then we have it is helpful in calculating the rates, because in the rate there is no place of the deviations. Okay, then what are the demerits of the harmonic mean? So first is it is difficult to calculate. HM is difficult to calculate than AM, since it is basic on the summations of the reciprocal of the original item. So when we reciprocate, so as you can observe that there is so much work with the decimal. So it is kind of complex, but I think this is not that complex as compared to geometric mean. But yeah, if you are comparing with the arithmetic mean, so it is calculator, because in the arithmetic mean we are just simply calculating the ordinal values, where there might be a chance where there is no decimal values, but in the harmonic mean we have to calculate the decimal values. So it is kind of calculative, and this is all about it. And then the second demerit is it not used by layman. So HM cannot be regularly used by layman, since it is based on the complex and the lengthy calculation. So if you have knowledge about the statistics and you have the command of it, so you can simply use it. But if you are expecting to be applicable to the common people, so it will not, because they have to be knowledgeable about it. But unlike the arithmetic mean, which is applicable in each and every copy, even student used to do it because the procedure is very simple. But here the procedure is kind of complex. Okay, then fails in case of 0. So HM cannot be calculated if the value of an observation is 0. If the observation is 0, okay, so if you are looking at the formula, so which is what? Reciprocal. HM is equal to reciprocal of xi, and divided by n, and divided by n. Okay, so if the observation is 0, and whatever the observation is there, so of course the HM will be turned to 0. But this is not an average. If the summation of so here this is written that it fail in the case of 0. So if an observation, if any kind of if the observation is 0, then it will fail. If you are taking one observation and it is 0, so in the 0 observations, the HM will be also 0. And then we have fail in case of missing value. So since the HM is based on all the observation which we have already studied in the merit, so of the observation, therefore HM fails in the missing. If some of the observation is not there, so HM will be not able to calculate like arithmetic mean and all. But when you will study the median or mode, so they will take just the few observations. So if some of the observation which is not applicable in their formula, if they are missing, so it will not affect their formula. But here all the observation present should be there. If there is an absence, then we won't able to calculate the HM. Then we have not used in further statistical studies. So here you can see that HM is a very basic formula. It is not that calculative, like it is not that complex. So let me give you let me give you some information that in the further analysis, arithmetic mean will be applicable rather than geometric mean or harmonic mean, because it is easy and the further analysis is kind of complex. So that is the reasons why harmonic mean will be not applicable. Then we will move to the positional average. We have completed the mean chapter, where there is harmonic mean, arithmetic mean and geometric mean. Then we will move to the positional average, which is also a part of the central tendency. So this is all about the harmonic mean. I will tune I think from tomorrow, and till then, take care.